I am Wally Lai. As one of the pioneer writers about space, I watched ideas I wrote about 20 years ago become everyday fact. Now I want you to come 20 years into the future with me on an imaginary journey to the planets. The journey is fiction, but the facts about the solar system and about the planets are as accurate as science can make them today.
Minus 45 seconds. Minus 40 seconds.
Telemetry and launch condition.
Affirmative. Minus 35 seconds.
Pressurization complete.
Affirmative. Minus 30 seconds.
Lock tanking secured.
Box tanking secured. Minus 25 seconds. Minus 20, 19.
Imagine you were in the shuttle boat with Willie Lay, poised above the powerful booster rockets, ready to begin our trip to the planets.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Fire. Mark.
Our trip to the planets has begun. The smaller streamlined shuttle carries us through the thick atmosphere of Earth toward the larger interplanetary ship. In the vacuum of space, the interplanetary ship coasts in a parking orbit, waiting for our space taxi. We slowly overtake the giant ship and prepare to attach ourselves to its side so we can board it. Our spaceship roars out of its parking orbit.
Back on Earth, when we plan a trip, we know that San Francisco will be 2 weeks from now where we left it today. And we know that we will find London where it was 3 years ago. But when we start traveling in space, our destinations keep moving at different speeds, and travel plans become a great deal more complicated. Fortunately, all of the 9 planets and their moons, the thousands of asteroids, and most comets move around the sun in the same direction and nearly in the same plane, which somewhat simplifies our navigational problems. We are headed toward the sun now. It is very much like going downhill, because the sun's enormous gravitational field pulls our ship toward it, just as it pulls all other bodies in the solar system toward it. But as the planets whirl around the sun, centrifugal force counterbalances the gravitational attraction. These two forces, centrifugal force and gravitational pull, are opposite and equal, which keeps the planets in their orbits and prevents them from flying out or from approaching the sun too closely.
The sun's gravity and our own momentum have taken us as close to the center of our solar system as we can safely go. So the captain turns the ship around. The engines are fired in the opposite direction to reduce our speed. The sun is gigantic. If it were hollow, 1,000,000 Earths could fit inside it. And it's noisy, too. This tape recorder is reproducing radio waves from the sun that are striking the outside of our ship. The sun is the source for almost all the energy in the solar system. But how does it produce this tremendous energy? Scientists believe the sun is mostly hydrogen, and the tremendous weight of such a huge mass creates superpressures and supertemperatures within its center. Under these conditions of enormous heat and pressure, hydrogen is turned into helium. But in the process, a small amount of mass is released as energy. This energy works its way slowly outward to the surface, relayed from atom to atom. It might take 50 million years for this energy to reach the surface of the sun, but it will take just a little over 8 minutes to get from the sun to Earth. Moving on past the sun, we approach Mercury, the smallest planet. Mercury is barely half again as large as our moon, while Venus is almost as large as our Earth. Scientists speculate that when Mercury was still a rotating and condensing sphere, the sun's strong gravitational pull caused huge ground tides on the planet's still soft surface. When Mercury finally cooled, these bulges hardened and began rotating with the rest of the planet, until the strong pull of the nearby sun on these bulges slowed the planet down. Now it can no longer achieve complete rotation, but only yaw slightly from side to side, keeping one face continually toward the sun. On the sunlit side, the sun's rays strike directly and eternally against the rocky surface and raise its temperature to about 700 degrees Fahrenheit. In contrast, the temperature on the dark side is 450 degrees below 0 Fahrenheit. The next planet out from the sun is mysterious Venus, hidden for centuries from our optical telescopes by dense clouds. Until we actually penetrate the cloud layer, we can only speculate about the surface of the planet. But we know energy from the sun filters through the clouds, heating the surface to 800 degrees Fahrenheit. However, the heat which comes back from the surface is trapped under the clouds, raising the temperature of the atmosphere. This heat once caused speculation that if water were present, the surface of Venus would be a vast, boiling ocean. The first Mariner space probe indicated that Venus is a dry, lifeless desert, since water could not be present at a temperature of 800 degrees Fahrenheit. Already, Venus appears smaller as we speed on toward the orbit of our own Earth. A day and a half later, just beyond our Earth, Mars looks like a red star. Still later, as we approach its orbit, we see that Mars has 2 tiny moons, the largest only 10 miles in diameter. Each spring, dark areas of the planet have been observed turning into a green-blue color, and scientists are fairly certain this seasonal change is caused by a simple form of plant growth. We're leaving our spaceship in a parking orbit about the planet to take the shuttle boat down for a closer look. The red coloring of the deserts of Mars may be caused by oxidation of iron in the large patches of sand and rock. Even in this thin Martian atmosphere, the winds develop high speeds. And with so much light sand on the ground, dust storms are frequent. It's a desolate landscape, and yet one can't help wondering if long, long ago, before the planet lost most of its air and water, there was ever intelligent life on Mars. A larger ship than ours, with a full team of geologists and their equipment, may one day give us the answer. When we leave Mars, we leave the group of inner planets. These planets near the sun, including our Earth and Pluto, the outermost planet, have certain characteristics in common. They are all relatively small, solid bodies composed of rock and metal. Because they are Earth-like, the Latin word for Earth, terra, is used, and they are called the terrestrial planets. Just beyond the inner planets is a ring of thousands of orbiting rock metal fragments ranging in size from a grain of sand to several hundred miles in diameter. These are the minor planets, or asteroids. Beyond the asteroids is the first of the gas giants, Jupiter. In fact, Jupiter is the largest planet in the solar system. The enormous speed of Jupiter's rotation pulls the gaseous surface into bands. The great red spot may be clouds over a huge floating mass of solid material. If we compare the Sun, Jupiter, and the Earth, we realize the great differences in size between the Sun and planets. Jupiter has 12 moons. The largest two are each as big as the planet Mercury. Some of the others are too small to be seen without a telescope, even this near the giant planet. We put our ship into a parking orbit again and take the shuttle boat for a look deep inside Jupiter's atmosphere. We don't really know what lies beneath the thousands of miles of atmosphere, but we're fairly certain that Jupiter and all the other giants are predominantly hydrogen. The surface temperature is very low. These outer clouds of the planet are probably made of frozen ammonia crystals suspended in an atmosphere of hydrogen and methane gas. Violent electric storms and winds of cyclone force churn the atmosphere. A blast of wind catches our wings. It flips our shuttle boat over and over, pulling us down deeper and deeper into Jupiter's unknown depths. The captain fires the rockets, and the boat surges forward, gradually moving upward to the outer edge of Jupiter's atmosphere. Now we must travel more than 400 million miles further out from the Sun to get to our next target, Saturn, surely the most unusual planet in the solar system. Besides its beautiful rings, Saturn has 9 moons. One of them, Titan, is the largest moon in the entire solar system, larger than the planet Mercury and almost as big as Mars. It is the only moon in the solar system known to have an atmosphere, and this atmosphere is mostly methane, a gas poisonous to man. At this enormous distance from the Sun, ammonia and some of the methane is frozen and looks like snow. The rings of Saturn are nearly 200,000 miles wide, but they are so thin they virtually disappear when seen on edge from a telescope on Earth. They may be no more than 10 miles thick and from a distance look quite solid, but the closer we get to them, the less substantial they appear. As our boat coasts into the outer ring, we find ourselves surrounded by billions of particles the size of grains of sand. Most of them are ice crystals, and they all glisten brilliantly in the sunlight. The remaining gas giants, Uranus and Neptune, are much like Saturn, except they have no rings. But since distances, even in our tiny solar system, are so immense, there isn't time to visit them. For even at 1,000,000 miles an hour, a trip back to Earth from Pluto at the outer edge of our solar system would take 5 months. Approaching Earth, the captain turns the ship around one last time. The rockets are fired to slow our descent to Earth.
Home looks good to us. It has an abundance of oxygen and of water and of the things we need for life. We're used to the length of its day and to the changing of the seasons. Yet we cannot help being curious about the planets. And one day, one of you who are watching now may be on the ship that makes the trip, which was only imaginary today.